I've never been afraid to tell others how I think software development should be done. And you know what? It's always just been my opinion. So I was intrigued when I found out there was a comprehensive scientific study of software development practices. The study is called the State of DevOps Report, and there's a book about it called Accelerate. Over several years, a team of scientists analysed tens of thousands of survey responses from people working on software projects at thousands of organisations all over the world. Their approach is peer-reviewed and gives us the most defensible findings about software development performance that exist. And they've come to some pretty amazing conclusions. There is no trade-off between speed and quality. In fact, it's quite the opposite. There is a correlation between high-performing engineering teams and business outcomes for their organisation. But even more significantly, this book gives us the ability to do something before was impossible, to compare the performance of software teams and identify which technical practices are most effective in a rigorous and evidence-based way. In other words, this book provides us with the means to step beyond just guessing. Let's dive into the book. It's split into three main sections. Part 1, what we found. This is about the outcome of the research, what the data shows us. Part 2, the research, which digs into the study's methodology. And Part 3, transformation. This is a case study of a real organisation implementing some of the recommendations from Part 1. I'm going to focus mainly on Part 1. In a way, it is Part 2 that makes the book so special. It's the science. It's a very approachable description of some complex statistical stuff. But today we're going to skip the working and go straight to the answers. So the first big problem with measuring performance is figuring out what performance is. There are plenty of bad ways to measure performance, for example, lines of code, velocity, that's a capacity metric, and utilization. It's also possible to measure performance badly by giving different teams metrics that conflict. For example, a dev team that's rewarded for changing things quickly and an operation team that's rewarded for things not breaking aren't going to work well together. If both teams follow their own incentive, the dev team will start throwing crap over the wall and the ops team will add a lot of obstacles to getting stuff done, which isn't a good combination for success. The book calls for metrics that focus on shared goals, so we don't pit teams together like that. It calls for metrics that focus on outcomes rather than outputs, so we avoid incentivizing pointless busy work. The book divides our work into two parts. The first part is product design and development. That's all the product work, the design, the UX, and the architecture, and the implementation. It contains a lot of the fuzziness of what we do. It's hard to estimate, and it very often doesn't go to plan. The second part is product delivery. That's the build, the testing, and the deployment. There's a lot less uncertainty in this part. And because this one is a lot less messy, that's what the research focuses on. It is simpler, but that doesn't mean it doesn't matter. Huge, impactful improvements can be made here, which is why I'm so keen to present this book to you today. In fact, good changes here make good changes in product design possible. It's much more possible, for example, to have an experimental approach to product development if you go from shipping once every 3 months to once a week or once a day. The performance metrics they identified are a combination of speed and stability. Let's start with speed. The first, lean time, is a classic lean metric. So normally lead time is the time it takes to go from a customer request to that request being fulfilled. But in the narrower space of product delivery, we're talking about the time it takes to go from some work being done to that being shipped. Shorter is better because it enables faster feedback on what we're building and allows us to react more quickly. The second speed metric is deployment frequency. More frequent is better because it gives us more predictability, quicker feedback again, and reduced risk. Moving on to stability, failure is inevitable, but it should be recovered from quickly. That's what mean time to restore measures. We should also try and avoid introducing bad changes into production, which is what change failure rate measures. The book provides evidence that these 4 performance metrics lead to better business outcomes. This is a big deal. I'm not putting up some lean metrics and recommending some lean approaches because that's the stuff I like and it's the stuff I've had good experiences with. I'm showing you metrics that are linked to success by peer-reviewed evidence. And it's not just business performance, incidentally. The evidence shows us that being good at these things leads to less deployment pain, less burnout, and increased job satisfaction. The data also shows us that there are no trade-offs between speed and stability. This is why I like this book so much. There are 2 plausible but opposite stories here. One is that going slow is safest, that taking time, gatekeeping changes, carefully manually testing will protect quality. The other story is moving fast is safe. And the best way to limit risk is by keeping the size of the changes small. Both stories make sense, but only one can be true. So how do we decide which is right? The answer is science, and that's what this book is about. As it happens, the second narrative is right. It is not necessary to compromise speed to get higher stability and quality. In fact, teams with higher speed tends to be the ones with better stability and quality. Teams that do try and preserve quality by going slow can keep their change failure rate low, but at the cost of absolutely ruining their mean time to restore. They lose the ability to recover from failures and outages in anything like a timely manner, which means when their applications do go down, they go down hard and they stay down. Here is a chart of software delivery performance in 2017. Our 4 metrics are on the left. It's split up into high, medium, and low performers. High performers can ship multiple times a day, get code from commit to production in under an hour, and they can fix failures and outages just as quickly. They have the lowest change failure rate. Low performers take days and weeks to do the same thing and have a higher change failure rate. Those low performing change failure rates are a percentage of a lower number because they deploy less frequently, but I'm afraid we can't give them credit for that because those failures tend to be much bigger and more complicated. Which makes sense. A failure deploying changes to 10,000 lines of code will in general have a bigger splash radius than a failure deploying changes to 1 line. There was a thing that surprised me. I had assumed that the high performance category would just be full of web developers, but it's not. Half of all teams are high performance, and the evidence shows that the age and type of technology a team uses is not predictive of performance. There are plenty of desktop and embedded systems developers in the high performance category, and a shiny new web stack is no guarantee of good performance. The evidence also shows that industry doesn't matter. It doesn't matter, for instance, whether an industry is highly regulated or not. Things like finance or healthcare just are not special. In fact, a lot of the stories we tell about why our contexts are different just aren't true. So the next question is, what drives software delivery performance? According to the evidence, what practices are associated with high performance? What do we do if we want to be high performing? Let's start with some non-technical ones. Culture is important. It's better to be performance orientated than to be rules-based or even fear-based. Lean product management practices combined with strong team autonomy are predictive of success. It's a good idea to build in security. In general, verifying your code for non-functional requirements only after the code is done isn't effective. This must be part of the software development process both early and continuously. A lightweight change approval process is important. Teams that need to seek external approval for changes deliver worse quality. And there are management and leadership practices as well, but I will leave some things unspoiled for people who want to read the book. What about architecture? I mentioned earlier that the relative shininess of our tech stack is not predictive of performance. But the choices we make are. High-performing teams are autonomous and loosely coupled. This is actually more predictive of success than either test deployment, test automation, or deployment automation. So it's a pretty big deal. What do I mean by autonomous and loosely coupled? I mean a team can make large-scale changes to the design of their system without the permission of someone outside the team, without depending on other teams to make changes in their system, and without creating significant work for other teams. They can deploy and release they can release their product on demand, regardless of other services it depends on, and they do most of their testing on demand without requiring an integrated test environment. Performing teams also tend to be able to choose their own tools, and during business hours, they're able to deploy with negligible downtime. High-performing organizations focus architecture on engineers and outcomes, not on technology. That means that architects should spend their time helping teams to be loosely coupled. They should not spend so much time worrying about this or that containerization platform, and they definitely should not be telling teams how to write their code. Continuous delivery. This is probably the biggest driver of software delivery success. It's a way of working where software is built in short cycles and can be quickly released to production on demand without manual steps. Building, testing, and releasing software is quick and frequent. Things like testing phases, code hardening, or code freezes are not practiced in continuous delivery. Continuous delivery requires continuous integration. We often use CI to refer to what we've written in Jenkins or TeamCity. And while you can't do continuous integration without a decent build and test pipeline, that's not what the term means. Continuous integration is a way of working. A team practicing continuous integration will integrate all their work into Trunk on a regular basis, at least daily. Each commit will build and test the software, and the team will prioritize the breaking build over any other work. The approach continuous integration takes to integration hell is to integrate more often. The only branching strategy compatible with the continuous integration is do not branch, or at the very least, avoid anything but short-lived branches. So trunk-based development is a requirement. You also need automated builds, configuration automation, and good, quick automated tests. There are some more drivers of continuous delivery: version control, deployment automation, continuous integration, trunk-based development, which we've already covered, test automation, test data management, built-in security, which we've talked about, loosely coupled architecture, empowered teams, and monitoring, keeping an eye on the production systems and their health. You'll notice there's a lot of hard stuff here. None of these capabilities is shallow and easy. We could have dug deep into all of them. And just because the science points to certain practices, that doesn't remove any of the intelligence or the creativity needed to apply them. Doing continuous delivery is very hard. What we can say for sure is it's worth it. If we do move to continuous delivery, we can enjoy better software delivery performance, better business outcomes, less rework, improved culture, less deployment pain, less burnout, and higher job satisfaction. That's quite a remarkable thing to be able to say with confidence. The evidence is in. What I've shown you is what the science says. And if you want to know any of my opinions that aren't backed by science, you can buy me a beer. Thank you very much for listening.